In this video, I'm going to cover several examples on how to approach different problems in 5.1, which the title of this section is Properties of Exponents, using properties of exponents. So, in order to attempt any of these problems, we first need to read through all of the properties on page 330, and I expect you to be able to identify the properties that you use in order to simplify and or evaluate the expression given. So with the first one, I have a product here raised to a power. So this is a power of a product, and I'm going to go ahead and use that property. And what that has me do then is it takes -4 and squares that. Alright, and the exponent on that -4 is 1. And I'm also going to be squaring 2 to the 5th. So what happens is I multiply my exponents here, so that becomes -4 squared and 2 to the 10th. Alright, and then if I were to actually go ahead and evaluate that, so that is power of a power. If I were to evaluate that, that would give me 16, and then 2 to the 10th is 1024. And then I can go ahead and multiply those. And my end result for this expression would be 16,384. Alright, so this would be simplify, and this would be evaluate. Alright, my next example, there's several different ways and orders that we can use. So the first one I'm going to go ahead and use is the negative exponent property, and what that tells me is whatever I have in the numerator, I'm going to take the reciprocal of that, so that's going to put it in the denominator, and if I have something in the denominator, when I take the reciprocal, it will put it in the numerator. So when I take care of that negative exponent, I result with 11 over 8 over 11 to the 5th. And now that's just to the first. So then I can take the power of a quotient and the power of a power. So power of a power and power of a quotient at the same time. Alright, and I can make that 11. 8 times 1, which is 8, and 11, 5 times 1, which is 5. And then, with that, I can take the quotient of a power. So then that becomes 11, 8 minus 5, which is 11 to the 3rd. That is equal to 1331. Okay, this is simplify, and this is evaluate. In the next section of 5.1, we discussed the scientific notation. With scientific notation, our end goal is to have one number to the left of the decimal place, and then how many ever other numbers as far as significant figures, and 10 to a power of some sort. Alright, so right here I'm just multiplying, so I can rearrange it and do 8 times 5 times 1.2, and I can take care of that number, and then I can do 10 to the 7th times 10 to the 3rd. So this is the product of powers on the right hand side. So what I can do is I can add and get 10 to the 10th, and then when I multiply 8.5 times 1.2, I get 10.2. Now I'm still multiplying those two. So in order to get this into scientific notation, I need to move that to the left, so that becomes 1.02, and because I moved it to the left, that's 10 to the 1st power times 10 to the 10th, so this is really 1.02 times 10 to the 11th, and that is my final answer in scientific notation. Carrying on to another example, so instead of multiplying here, I'm going to divide. So I'm going to break this into two pieces. So I'm going to break it into 6 over 9, which I know that reduces to 2 over 3. That step is not necessarily important. And then I have 10 to the negative 4th over 10 to the 7th, and then I multiply those across. So I have 2/3 times, this is the quotient of powers. Alright, so I subtract. When I multiply, I add. And when I divide, I subtract exponents. So this is 2 times 10 to the negative 11th. And then our next step is to deal with that negative exponent, because I don't like to leave exponents negative. So that becomes 2 over 3. Now that would drop down bottom, so it's like 2 over 3 times 1 over 10 to the 11th. So I can just put that 10 to the 11th down with the 3. And that is as simplified as it can get. Alright, and with this example, I have the product of powers, so I'm multiplying various pieces, all raised to a power, so I add the powers since the base is the same. Alright, and that gives me b negative 4th plus 13 and b to the 9th. And that is just nice, simple, and concise. Our next example, we have multiple steps for this. So first I'm going to go ahead and use power of a quotient. I'll work in a different order than I did before. Power of a quotient. So what that means is I need to distribute, in a matter of speaking, that exponent to both of the exponents and multiply. So that becomes r to the negative 2 times negative 3 power, and s to the 3rd power times negative 3. So I get r to the positive 6th power over s to the negative 9th power. And that's almost finished. However, that negative exponent allows us to take the reciprocal and move it from the denominator to the numerator. So that becomes r to the 6th, s to the 9th. And that is its fully simplified form. And in our last example for this section, we have numbers, and we have two different types of variables. So I'm going to go ahead and break it into the coefficients here, times m to the 4th, I'll put it over 1, why not, and times n to the negative 5th over n to the negative 5th. All I did was break it into pieces so I can deal with each. So this becomes 8 over 1 times n to the 4th over m to the 4th over 1 times, this is the quotient of powers. So I have negative 5 minus negative 5, and that gives me 8 m to the 4th. That's still over 1, but that becomes, this piece becomes n to the 0th, which is just 1. So I don't need to multiply that by 1, as it will stay the same since it's an identity. So it's just 8m to the 4th. If you have questions on this section, please feel free to send me an email or see me before school.